Today we will practice balancing chemical equations. When using a table to organize your numbers as pictured here, the first step is to list the elements. In this single replacement reaction, the elements that we have are iron, oxygen, and carbon. Next, we will count atoms on each side of the equation, on the reactant side and on the product side. So on the reactants, we have 2 iron atoms. You can tell that by looking at the subscript there. And we have 3 oxygen atoms and only 1 carbon atom. On the product side, we have 1 iron atom, as indicated by the fact that there's no subscript next to the iron. We have 2 oxygen atoms and 1 carbon atom. As we balance, we will apply the law of conservation of mass to get the same number of atoms of every element on each side of the equation. Remember, in chemical reactions, atoms are never created or destroyed. The same atoms that were present in the reactants are also present in the products. They are merely reorganized into different arrangements. We'll use coefficients to balance. So we can put numbers in front of any element or compound in order to balance the equations. We do not change the subscripts. If you take a look at your table, you'll notice that the iron number is unequal and so is the oxygen number. So if we balance in order, we can start by placing a 2 on the product side in front of the iron, and that'll balance out the iron. So now the iron atoms are equal on both sides. Now let's take a look at the oxygen. Notice how we have 3 on the reactant side and 2 on the product side. When we encounter numbers like that, we want to look for a common multiple. So what we can do for oxygen is make oxygen equal to 6. The common multiple between 3 and 2 is 6. So to make oxygen on the reactant side 6, we can put a coefficient of 2 in front of iron 3 oxide. So now oxygen is 6, but notice how the iron has also changed. Instead of 2 irons, we now have 2 times 2, which is 4 iron atoms. Let's go ahead and adjust the oxygen on the product side to make sure they balance out. So we'll put a 3 in front of the carbon dioxide. So 3 times 2 gives us 6 oxygens, but that also changes the carbon. So 3 times 1 is 3 carbons. So now let's go back and fix the iron. Instead of having 2 as our coefficient on the product side, we can change that to a 4. And now the irons are equal. And we can go back to the reactant side and put a 3 in front of the carbon to make that balance. And now that you check both sides of your table, we have 4 irons on each side, 6 oxygens on each side, and 3 carbons on each side. So now we know we're balanced. When listing the coefficients of this balanced equation, the coefficients would be 2, 3, 4, 3. This would be the correct sequence. In example 2, we only have 2 elements in this synthesis reaction. Let's try this without a table. Remember to use only coefficients to balance. The subscripts will not change. Notice the 2 and the 3 on the oxygen. We will need a common multiple here. Let's start balancing oxygen first this time. The common multiple between 2 and 3 is 6. We will get 6 atoms of oxygen by placing a coefficient of 3 in front of the O2 on the reactant side. We will get 6 atoms of oxygen by placing a coefficient of 2 in front of the aluminum oxide, Al2O3, on the product side. Now all that's left to do is to balance the aluminum. 2 times 2 equals 4 aluminums on the product side. So to balance out the aluminum on the reactant side, all we have to do is place a coefficient of 4 in front of aluminum. The sequence of coefficients then to balance this equation is 4, 3, 2. In example 3, we have a double replacement reaction. Let's use the table to list our elements: hydrogen, fluorine, magnesium, and nitrate. Do you notice the polyatomic ion nitrate on both sides of the equation? If you notice a polyatomic ion on both the reactant side and the product side, keep the polyatomic ion together and treat it as one unit. It is more efficient and simpler to balance this way. Let's begin balancing by counting up the atoms and ions on the reactant side of the equation. We have 1 hydrogen, we have 1 fluorine, 1 magnesium, and 2 nitrates. On the product side, we have 1 magnesium, 2 fluorines, 1 hydrogen, and 1 nitrate. Notice right away that the fluorines and the nitrates are not balanced. So we can go in order and balance them, starting with fluorine. To balance the fluorine, we'll need a coefficient of 2, so we'll place that in front of the HF molecule. That changes our number of fluorines to 2, and our number of hydrogens also to 2. Now that the fluorines are balanced, let's look at the nitrate ion. We need to make sure that the nitrate ion is balanced, and we can do that by putting a coefficient of 2 on the product side in front of the HNO3 molecule. That change makes our hydrogen atom on the product side equal to 2 and the nitrate also equal to 2. So you can see now that the hydrogens are balanced, the fluorines are balanced, the magnesiums are balanced, and so are the nitrates. Our sequence of coefficients in this balanced equation then is 2, 1, 1, 2. Example 4 is another example of a double replacement reaction. Perhaps you notice that it's also a neutralization reaction since we have a base and an acid. Did you notice the polyatomic ions present here? Remember to treat the polyatomic ion as a single unit when it appears on both sides of the equation. Before we begin balancing, let's take a look at the different polyatomic ions we can see. Did you notice ammonium appear on both sides of the equation? Hopefully you also noticed the sulfate ion on both sides of the equation. And then lastly, we also have hydroxide. Can you spot it on the product side? When balancing neutralization reactions and noticing that you have a base and an acid, make sure to rewrite water as HOH. When you have a neutralization reaction and you notice the hydroxide separate from the hydrogen on one side of the equation, it's much easier to treat the hydroxide like a separate polyatomic ion when balancing. Let's try balancing this equation without a chart. If we go in order, starting with ammonium, you'll notice that there are 2 ammonium ions on the product side because of the subscript there. And so to balance that out on the reactant side, we'll simply put a coefficient of 2 in front of the ammonium hydroxide. Now that the ammoniums are balanced, let's look at the hydroxide ion. We have 2 hydroxide ions on the reactant side. To make it balanced on the product side, we'll put a coefficient of 2 in front of the water. That change now means we have 2 hydrogens as well as 2 hydroxide ions. So if we go to the reactant side, you'll notice that the hydrogens are already balanced because of the subscript 2 on the reactant side. And if we take a look at the sulfate ion, Since there are no other subscripts outside of the 4 that belongs to the sulfate formula, we know that there's 1 of that ion on each side. So it's already balanced. And that's it. We're done with example 4. The coefficients for this balanced equation then are 2, 1, 1, 2. Our last example is an organic combustion reaction. You'll note that it's organic combustion because we have a hydrocarbon, which is an organic molecule, combining with oxygen or reacting in the presence of oxygen to produce carbon dioxide and water. The easiest way to balance these organic combustion reactions are to balance them in order, starting with carbon, then hydrogen, then oxygen. To balance the carbon, let's begin by putting a coefficient of 2 on the product side. Since we're sticking with balancing in order, now let's take a look at the hydrogen. We have 6 hydrogens on the reactant side. To make the hydrogens equal, we'll place a coefficient of 3 on the product side in front of the water. Now that we balance the carbon and the hydrogen, let's look at the oxygen. On the reactant side, we have 2 oxygen atoms. On the product side, we have oxygen in 2 spots, in carbon dioxide and in water. When we count up our total number of oxygens, we have 4, 2 times 2 is 4, plus 3 times 1 is 3. 3 oxygens, 4 plus 3 is total 7. So we have 7 total oxygens on the product side. The only way to get 7 oxygens on the reactant side is to put a 3.5, a fractional value, in front of the oxygen molecule on the reactant side. Now, when balancing, we want to avoid having decimal places in our coefficients. So the easiest way to get rid of a fractional coefficient is to multiply it by the lowest number, the lowest whole number that will make that coefficient a whole number. So with 3.5 or 3.5, the easiest way to do that is to double all of the coefficients present in this equation. So we will simply multiply all of the coefficients by 2. When we multiply everything by 2, then our coefficients are 2 times 1 is 2 for the hydrocarbon, and then 2 times 3.5 becomes 7. 2 times 2 becomes 4 carbon dioxides, and 2 times 3 becomes 6 waters. So our sequence of coefficients to balance this chemical equation is 2, 7, 4, 6.